Hello, sixth grade. So you're in class. I hope you're behaving and you're done with the reading about energy transformations. Now you know energy can change from one form to another. So this is the part of class where we would do this foldable together. I'm not there. So I'm going to try to do it from home. So let's get started. You should already have your worksheet out. Make sure that your first name, last name is up at the top, that you have the period in the corner, and we are ready to begin. So I'm using Cami, and I already typed out some stuff. So I'm just going to kind of talk a little bit about what's happening on each of those pages, and go into a little bit of a description if we need to, and then you'll paste this in. I don't think you guys need to turn this in. If you just paste it in, we'll be in good shape. So the worksheet is called Energy Transformations. And the first thing that we need to know is that almost all of the energy on Earth, in fact, it's like 99.999, it's like almost all energy on Earth comes from, you can probably guess what that is, the sun. If we could figure out a way to harness more energy from the sun, even just if we could get all the energy the sun produces in just 1 second, we could power all the electrical equipment on Earth that we would want for over 1 million years. In fact, I think it's a little closer to like 2 million. That's how much energy the sun produces. And we're only able to capture a very small percentage of it, unfortunately. So scientists are working on that, trying to figure out how to do that better. Now, the other thing we want to remember, and you just read about this, is that the law of conservation of energy states that energy is neither created nor destroyed. It just changes or transforms from one form to another. And that's been happening ever since the universe first formed. We don't have any more energy, we don't have any less energy. The energy just gets changed around and goes around all over the universe. Here on Earth, most of the energy tends to stay on Earth. And I think we're done with the first page. So let's go to the second page now. For you, that's going to flip over to the back. All right, so here's our second page. We're going to do a few examples of energy transformations together to help you understand the concept. So the first one we're going to look at is over here in the top left corner, and this is using a toaster to make waffles. Waffles are great. You'll see that the toaster that we're using is unplugged. That means that before we can use it, we have to plug it in first. So to plug it in, we have to use mechanical energy. Now that's going to go in the box down here closer to the cord because the cord has to be plugged into the wall. Once we plug into the wall, then we can use electrical energy. The electrical energy, you'll see, is kinetic energy because it's the flow of electrons that go through the cord and through the toaster to produce the kind of energy we need to cook our waffles. So we have our starting energies here on the left side. Take a minute, think about what energies are being produced over here on the right side. So the electrical, mechanical, in other words, what are they being transformed into over here on this side? And you'll see there are four. The more you think about it, the more you can come up with. If you're still kind of getting the hang of this, you might be able to think of one or two. Now, the first one that comes to mind is going to be thermal energy. If we're going to cook a waffle, we need thermal energy to do that. So that's the first one that we should list. Now, what else? Think about a toaster. What else do toasters do? Well, the toaster has to pop out of the toaster. So that's mechanical energy. Some of the mechanical energy that we use to plug in the toaster and to push this little knob down to get the waffle going, cause it to pop back up as well. So if you're paying attention when the waffle is cooking, you might also notice that we're going to see some radiant energy, which is light, and sound energy. Sound energy occurs when the waffle pops up out of the oven. It might not be a lot of sound, but yeah, it does produce some sound. So this is an example of energy transformation for cooking a waffle in a toaster. Let's go on to a second example. So now we're talking about striking a match to produce. Here's a hint right here. So I'm going to let you think about it for a sec. You can pause the video if you need to, and then I will guide you through this one as well. So, first of all, the match itself has energy stored in it that is potential energy. So, the first type of energy we're going to see with the match is going to be chemical energy. Chemical energy is the energy stored in matter just because of its composition. Just the fact that it's matter, it's going to have some energy. But the match isn't going to light itself. To light the match, we're going to have to use some mechanical energy. You got to rub, rub the match against the box, or sometimes they make matches that you can just rub against any surface, and the friction will cause it to light up. All right, so we use the match, we struck the match. Well, why is it we're lighting a match anyways? Most of the time, I can think of two reasons why we would light a match. The first reason I would light a match is because we need the fire or the flame, which is thermal energy. Now, I know that sometimes, when people light a match, they're trying to light up a room. So the second reason might be for the radiant energy. Radiant energy is another term for light in science. Now, there's a third one that sometimes people don't think about, but when you light a match and the match is burning, you can usually hear the crackling sound of the fire burning. So we're going to include sound as one of the energies that's produced during this transformation. So we have the match, we strike the match produces fire, the match produces light, and we can hear the match burning. So we're going to stop here for a second to just talk a little bit about byproducts. Byproducts are things or sometimes kinds of energies that are produced that we don't necessarily need or want. And most times, whenever we have an energy transformation occurring, there are two kinds of energies that we really don't want happening. Sometimes we do, but not always. So down here in the middle of the page, you'll see it says usually blank and blank energies are byproducts. The first one is going to be thermal energy. Yeah, we lit a match, we lit a toaster, we didn't want the fire, but lots of times we don't want thermal energy. So when you're driving a car, you don't want your car overheating, and a lot of the energy produced by the car is thermal. So we could figure out a way to have cars run and not produce so much thermal energy. That'd be better for our planet too. Also, light bulbs. We're always trying to make light bulbs that don't produce as much thermal energy because it's wasted energy. If we could have light bulbs that produced 100% light and no thermal energy, that would make you a lot of money too. Now, the second type of energy we usually don't want is sound. Normally, when we do things, we want it to be quiet. We don't want a loud dishwasher. We don't want a loud washing machine. So sound is sometimes considered a byproduct energy too. All right, so let's move on to our two other examples here at the bottom of the page. So now, putting batteries in a flashlight to produce, what we use flashlights for. So take a minute, think about what kind of energy the battery's going to have, that process we need to get the flashlight going, and then what's produced. All right, let's do this. So the batteries, some students may think, have electrical energy in them. They don't have electrical energy. Batteries actually have chemical energy stored in them. The chemical energy, when you connect the battery to a circuit, is what produces the electrical flow. So in order to get the battery going, you got to flip a switch. So in order to flip the switch, we got to use that mechanical energy. Now, when that happens, when we flip the switch, this causes another change here in the middle that produces these three forms of energy over at the end. So I'm going to go ahead and include that now, and that is going to be the electrical energy, which is also kinetic energy. So we flip the switch, That causes an electrical flow, and the electrical flow is what gets the flashlight working. So next, we're going to have I have to type this one in. The radiant energy, which is kinetic energy. And that's the light that comes out of the flashlight. Now, when you get those batteries plugged in and the electricity starts flowing, unfortunately, it does produce thermal energy. So this flashlight with the batteries in it can start getting pretty hot. And then the last form of energy we may notice when we turn on the flashlight is going to be sound. We really don't need the sound, but it happens, right? Okay, so there we have our flashlight taken care of. So we start off with the chemical energy in the battery. We flip the switch to get it going. That produces the electrical energy, which in turn causes the light to happen, starts getting hot, and sometimes it'll make a sound. So you get that little click when you get the flashlight going. Okay? So we have one more to do together right here on this page, and then we have another example from biology, life itself. So the next one everybody's pretty familiar with, and this is what happens when we're using a computer. So do me a favor, pause the video. Let's see if you can figure it out by yourself first before I go over this one with you. Okay? All right, let's go ahead and go through this one together. So very similar to the toaster, we have to plug in our computer into the wall. So that is mechanical, which is kinetic energy. Once we plug it into the wall, we can get the electrical energy flowing to the computer. That's also kinetic energy. So now the computer's plugged in, we turn it on. What four forms of energy is our laptop or computer going to produce? So think about, why do we use a computer? Most of the time we want to see something on the screen. So that's going to be radiant energy, which is light. If you're playing games or watching a movie or something, you're going to want to be able to hear it. So sound is something else that's produced, and this time we do want that energy. Now, like most other electrical things, your computer is going to start getting hot. Unfortunately, we don't want it getting too hot because that can mess it up. That's thermal energy. Which is also kinetic energy. But I don't know how many of you are aware of this, but most computers have a little fan inside of them. And the little fan is an exhaust fan that blows out some of that thermal energy. So we can also list mechanical energy here as an energy that's produced. Mechanical. Let's hope that fits in here. Let me scoot this over a little bit. Move that over a little bit more. I think that'll do it. There we go. Mechanical energy. So we plug in the computer. That gets an electrical circuit going that flows through the computer. So we see the things on the screen, that's light energy. We can hear the sound coming out of the computer. The computer starts getting hot because it has the battery in there. And then talked about the exhaust fan in there. And you also have to type on the keyboard and move the mouse. So that can also be part of the mechanical energy. So I want to pause here before we go to the last page and just point out that if you think about it, you can tell a story about what happens with the energy transformations. So keep that in mind as you're looking at the forms of energy and how they change. You can make the story of how these devices and different things work. Okay, let's go to take a look at the last page, and this last page is going to have, like I said, an example from biology or life science. Okay. So you'll see that we have the sun up here, and you can see that's the sun is giving some energy to some carrots down here. So we said that the sun is like the main source of energy and almost all energy on Earth. The sun produces two kinds of energy. What are those? Those two forms of energy are going to be thermal energy and radiant energy. That's going to be the heat from the sun that keeps our planet warm, not too warm, but warm enough that there's life. And then radiant energy is the light that comes down to our planet and can help plants to grow. Now, the process that plants use involving light in order to grow has a name. And you guys should remember this from last year. That term is, whoa, went too far. Let me move back a little bit. There we go. Photosynthesis. Photosynthesis is a chemical reaction that involves sunlight, water, and carbon dioxide. And the sun uses the plants use the carbon dioxide and the water to make sugar using sunlight. You'll learn a lot more about that in seventh grade. So when the plants do photosynthesis, they are producing chemical energy. This is the energy that is stored in all plants, just like our carrots here. So we're going to learn later on in the year, and you probably already know this, that plants are producers. So they produce the energy for other organisms to eat. So we could say that this guy over here, this rabbit, is a consumer because he is eating or consuming the carrot. So in order to consume the carrot, eat the carrot, he or she, could be a she, uses mechanical energy to munch down on that carrot. And when the rabbit eats the carrot, it converts that chemical energy into other energy that it uses in order to do things. That process of breaking down the food is called metabolism. And you're also going to learn a lot more about that in seventh grade. I want you to write that down. And I want you to write down that metabolism just basically means for now burning up food for energy. You do the same thing. Anytime you eat, your body digests the food, breaks it down into smaller particles, and then those particles and the energy left over go to our cells so that our cells can function and help us grow, help us do things. All right, so now our rabbit's eaten. It has the chemical energy from the carrot inside of it, and it's going to use that energy to do a few things, like it says here, hop. Well, hopping is going to be mechanical energy. And if you're close by, you might even hear it moving around. That's also kinetic energy in the form of sound. But there's other things that happen. The rabbit, because of the metabolism, is going to produce thermal energy. Any animals or organisms that eat food are using that metabolism to make energy, and in turn, produce a lot of thermal energy too. That's why when you exercise more, you get hot, you start sweating. Now, I'm sure there are a few of you watching this video who figured out that there's something else that happens. There's another form of energy that I haven't included yet. So, to kind of explain it to everybody else, guys, let me go ahead and do this. The rabbit is also going to produce chemical energy. Now, that chemical energy the rabbit is going to produce comes from digesting that carrot. It's going to poop. It's science class, guys. This is science. And that chemical energy, is used by plants as fertilizer to grow bigger, do other things. And also the rabbit eventually will die. And when it dies, its body will decompose, and all the materials it's made out of will be absorbed into the soil and used by plants again. Circle of life. You've seen Lion King. That works, right? And that's pretty much the way that energy transformations work in living things. Now, at the bottom of the page, you're going to see it says "Do your own." So now I want you to set up your own flow map to show how an energy transformation occurs for something that you're familiar with. So I put here, think of a process that you're familiar with. Let me get this out of the way. Since Thanksgiving is coming up soon, you might want to think about, uh-oh, there we go, cooking a turkey. Cooking a turkey in an oven. So you might want to tackle that. And you can set it up just like I did on the last page on this page. Just write the forms of energy in the boxes and then give a little explanation as to what's happening in your energy transformation. I hope this helped. I hope this makes a little sense. When I see you on Monday, we do have another assignment activity involving energy transformations that we will be working on. So let's get this done, guys. If you don't finish it, it's okay. Don't worry about doing it for homework. I'll try to give you a little time on Monday to get this done. Okay? All right. Well, I'm hoping that you were able to get this done before the end of the period. Have a great day. Have a good weekend. And I will see you on Monday. Take care, guys. Enjoy your weekend.